Okay, I see students are joining again.
Sir, can you please explain the capillary action of that means in plastic stage how the cutting fluid will go by the capillary action?
Yes, yes, definitely. I'll do that. Okay, if you look into this diagram, okay, if you look into this
Yes, sir.
diagram, what happens is there is some amount of gap here into which the cutting fluid enters. However,
Okay.
this portion where is the plastic zone, the gap is not there, right? So, however, there is some channel, even if there is no gap, even if the tool is in contact, means close contact with the chip, still there is a possibility of some fluid to enter. Okay, so that fluid enters due to the capillary action, and this entire rake surface and chip tool contact is being lubricated. Okay, is it clear?
Okay, sir.
Okay,
So means the fluid is forced inside
yes,
the
definitely.
gaps.
Yes, yes, definitely.
Okay,
The
okay.
fluid is forced in. However, it do not get into this portion due to that force, but it gets into this due to some capillary action. Capillary action you have
Capital.
studied in fluid mechanics, that
Yes, sir.
uh,
Yes, sir.
if there is any kind of very tiny means channel, so the fluid is being pulled in that channel due to some capillary action.
Hmm.
Okay,
Yes, sir.
all right.
Okay. Okay, sir.
All right, so I'll continue.
Yes, sir. Continue.
Okay, fine. So I was almost at the end of this slide. Okay, so last topic of this chapter is methods of application of the cutting fluid. And in machining, depending on how we means depending on the requirement, like what type of tool material combination we are using, what type of cutting means parameters are there, depending on that we select different types, different methods of uh, application of the cutting fluid. So these are the different types, that is drop by drop under gravity. We just uh, uh, means just drop some cutting fluid on the machining zone, maybe at the chip tool interface, maybe at the place where the maximum cutting temperature is generated. Next is the flood under gravity. Now we have seen this flood under gravity whenever you have performed any kind of machining in the lathe machine. So there is an pipe kind of thing, and there is a nozzle. So cutting fluid is forced in the form of, as if it's flooded with cutting fluid. Okay, and it is provided or it is flooded into the machining zone in the form of liquid jet. We can also have some liquid jet so that it is more like localized. Okay, then mist is we can mix the cutting fluid with the compressed air. So a mixture of compressed air and mist is thrown into the machining zone. In this case, what happens, the cutting fluid or the material lubricant uh, consumption is very less. So some atomized oil is used here. Okay, and it is atomized in the because it is pushed in or thrown in the form of mist along with the compressed air. And last one is the ZZ method, centrifugal through the grinding wheel ports. Now, the direction of the application also significantly governs the effectiveness of the cutting fluid in respect of reaching at or near the chip tool and work tool interfaces. Like as I told you, that chip tool interface is a secondary zone where the maximum amount of heat is generated. Around 70% of the heat is generated at the chip tool interface, 15% at the you can say at the primary shear zone, and 15% at the work tool interface, that is at the worn out flanks. So please remember this: 70% of the heat is generated at the chip tool interface, and the remaining two parts, you can say 15% each, at the primary shear zone and 15% at the worn out flanks. Okay, so this is the distribution of the heat at the machining zone, and depending upon the requirement and accessibility of the cutting fluid, it is applied from top or side in operations like deep hole drilling. Some uh, you can say pressurized fluid is often sent into the axial or inner spiral hole of the drill. So in case of drilling, again, some fluid is pressurized through the drill, or there are some fluids in the drill. Okay, so some what will happen in that in case the fluid is not pressurized, the drill will not be, the drill bit may break down, and it will not be able to perform the machining properly. So for effective cooling and lubrication in high speed machining of ductile materials having wide and plastic chip tool contact, like if the plastic chip tool contact, which we just have discussed few minutes back, if it has a wide contact, because in case of ductile materials, what will happen, continuous long chips will be formed, and maximum portion of the chip will remain in contact with the rake surface. Okay, so in that case we have to push the cutting fluid at a higher pressure, as Somnath was asking, that in case we are unable to in case we are unable to reach the proper zone, in that case what will happen, the proper zone will not be cooled, so we have to create some extra pressure into the chip tool interface. Okay, and by which we can get the proper cooling. Now this is the ZZ method, right? Uh, you don't have to get into the details of all these things. In case you want to, please also go through your books. This ZZ method is also provided in the books. However, since we are discussing normally about the turning process, and the ZZ method is grinding process. Okay, so I'll quickly show you what exactly happens here. So here, this is the grinding wheel, this is the side portion, this is the cross section of the grinding wheel. So here the fluid is passed on from the axis of the wheel. Okay, and it is transferred to the wheel in this manner, right? So this is the ZZ method of the application of cutting fluid in case of grinding. So in few cases where there are cut means no place, suppose in this case you have this plastic zone, a wide one, so it is not possible to pressurize the fluid into this plastic zone. So what happens, at times we can make a slot into the tool holder as well in the tool, and we can put the cutting, or we can pressurize the cutting fluid through this so that it reaches the plastic zone, right? So the application of the cutting fluid at a high pressure through the hole we have made, there is a slot that can be made in the tool, and through this slot we can create a proper uh, proper cooling can be performed, right? Okay, next is your this is next we are going to discuss about our broaching operation. So kindly bear with me, right? In case you have any doubt regarding this, I'll open the session for a doubt clearing, then I'll move on to the next portion. In case you have any doubt, please you can ask me.
Hmm.
আমার সবাই বলছে ভাই বাড়িতে এত ঝগড়া হচ্ছে না, আর ভাল লাগছে না।
You are audible. Whoever is saying
সব
বাড়িতে ঝগড়া
বাড়িতেই
হচ্ছে
তাই
is
শুনি
totally
এখন।
audible. Okay, if you want to say
সব
something
বাড়িতেই তাই শুনি।
regarding this,
সব
please
বাড়িতেই
talk.
তোমরা
Else
জানো না।
don't you keep yourself mute. Okay. So I think there is no questions. So let me move to the next topic. Right. So next is we are going to discuss about the broaching operation. So this broaching operation is a operation which is performed, which is a multi point cut tool, which is using a multi point tool, and this operation we can say it is successive turning process. Okay, so let us see what we are going to understand in broaching, so we can understand the principle of broaching. We will see the different types of broaches that are available, and we can also identify the limitations and advantages of broaching. So what is a broach basically? So broach is a tool which comprises of different small tools in it, and they are placed in a series. So as you can see, suppose you want to machine a certain depth of or a certain amount of portion. Suppose this is the portion that you want to machine using turning operation. So what you are going to do in case of turning, you are providing some amount of depth of cut. So the material is removed depending on the provided depth of cut. For example, you have a diameter of 50 mm and you want to reduce the diameter of the shaft by 5 millimeter. 50 mm is the initial diameter. You want to reduce the diameter by 5 millimeter, and you can use 5 uh, turns by or 5 passes by which you can reduce the diameter into 45 mm. So if you provide a depth of cut of 0.5, then you can, on both the sides the material will be removed. So in each pass 1 mm material will be removed. So in 5 you will require 5 times turning you have to perform. However, in this case, if you arrange the tool in such a manner that you have given a certain amount of depth of cut here, and the next tool will, suppose the difference in height in this is the depth of cut. So the successive or the adjacent tool will have a provided given depth of cut. Okay, so this is the amount of depth of cut that you are getting, okay, in each pass. So if you are moving, or if you're fitting this tools in a same you can arrange it in a proper tool holder or something, and in one stroke you can get the entire material removed. So you can see here, broaching is a machining operation for removal of layer of the material desired width and depth. Okay, this is a very important factor, desired width and depth, usually in one stroke by a slender rod or bar type cutting. Like this type of tools are fitted on a cylindrical bar, or we can say rod. Okay, so which has a series of cutting edges are there, which with gradually increased protrusion. So the increased protrusion, this is the amount of depth of cut that I want to provide in the uh, workpiece or in the tool. Like I, in each run I give the depth of cut. So this is the value, increased value. Is in shaping, what happens, the attaining full depth requires a number of strokes. Okay, so number of strokes are required to remove the material in different layers, step by step, gradually. Okay, because it's a single point cutting tool. So in case of shaping or shaper operation, one stroke is done, you have to do a cross feed, and then another stroke. Again, you have, if you want to remove material from the machine zone, again you have to repeat the process. However, in broaching, what you can do is you can do it in the, you can remove the entire material. The whole material can be removed in a single stroke. Okay, only by gradually rising the teeth. Only by gradually rising the teeth. Okay, that teeth means the cutter which we have here. That cutter is called the broach. Name of the cutter which we are using here, that cutter is called broach. Okay, so the amount of tool rise between the successive teeth of the broach is equivalent to the infeed. Infeed, why we are saying, we are not saying depth of cut here, because we are relating this process to the shaper or shaping operation. Okay, so this is a difference between the shaping operation and broaching. So in case of broaching, in case of shaping, we give an infeed. There is not a depth of cut that we give. We get an infeed and cross feed. Okay, depending on in which parts the material has to be removed. So this infeed distance is provided in the broach, and we can get the entire material. We can remove the entire material in one go. Okay. Now, okay, I see Somnath has a raised hand, so I'll get back to him. Yes, Somnath, you want to ask something?
Yes, I was asking that in broaching operation, the feed doesn't remain constant. Means it is changing with the means the broaching tool. Means in
Uh,
every
yes,
part.
in the feed is constant. However, you don't have to provide the feed in every pass. It has already been provided.
Okay.
Okay, and when you move the tool uh, on the workpiece, what happens? The material is removed in one stroke.
Okay,
So
sir.
the
And sir,
force
one
need
more
is more,
question.
no?
Yes,
The force will be more, means the feed
yes,
means
definitely the
we
force
apply.
required will be much more. Okay,
Yes.
than the normal. Like suppose, just think about an idea wherein you are cutting a material with a single blade, and you're cutting it with a saw. Okay, so when you're
Yes.
cutting it with a saw, you have to provide a certain amount of force, because the saw is not very smooth. So definitely more frictional force will be there. So you have to overcome that friction. So more force requires to be applied, right?
Okay. So I have another question.
Yes, please.
So means when we are creating key slots inside a hollow shaft,
Yes.
so is broaching the best method of
No.
doing that?
No, see, broaching can be used for creating hollow shaft, I mean slots. However, there is a special machine called slotting machine, okay, which can be used for creating slots. Slotting machine, I believe Professor Gautam Pal has already discussed about the machine tools. In case he has not, he'll discuss about the different types of machines which are available, like lathe machine, shaper machine, milling machine. You already know. There are other machines apart from that, like slotting machine is another type of machine, which is specifically, or we can say it's a special purpose machine for generating slots in hollow shafts. Okay. However, yes, this also can be used. You have, as you have rightly pointed out. Okay. So, any more questions? Can I proceed? Okay. So, since I see there is no more questions, I'll proceed. So, right. So now, machining by broaching is preferably used for making straight through holes for various forms and sizes of section, internal and external, through straight or helical slots of or grooves. As you said correctly, that slots can be made using this process. Okay. Now, External surfaces of different shapes can be made. Teeth of external and internal splines and small spur gears can also be produced. So you can see there is a, this is what a broach looks like, right? This is a vertical push type broach, and there's a horizontal pull type broach. Push type and pull type, there are two things. As you can see here, if it's a push type, you're applying the force from the top. So I'll use the arrow here. So you're applying the force from the top, and this push type will means face some kind of compressive force, and due to this compressive force, chances of buckling is very high. Okay, that is why push type broaches are made shorter in length, because if you make a long push type broach, what will happen is when you are trying to push it down, what will happen, there will be buckling, and the tool will be damaged, the broach will be damaged, right? And for a pull type, that is not an issue. Sorry, uh, this is not the direction. However, this is the direction in which we are pulling the broach. As this teeth is gradually increasing in this direction, so as we are pulling it in this direction, material is being removed from the workpiece. Okay, in for each and every step, and we are getting the desired shape, okay, or desired size rather. Okay, so construction and operation of broaching, it is characterized mainly by the configuration, material, and the cutting geometry. So the broaching tool configuration, if you try to see the diagram here, this is the you can say both pull type and push type broaches are made in the form of bars or rods, okay, which has varying cross section as in different size of or heights of teeth are placed. Okay, now here we have a pull type broach. So this is the pull end, there is a neck, right, for proper holding of the broach. And then we have a front pilot. Front pilot means this pilot portion should smoothly enter the hole, okay, which we are trying to increase in length, increase in size. Then we have the range of cutting teeth. Then as you can see, the range of cutting teeth, okay, they are spaced equally, I mean spaced at equidistant to each other, and the spacing is much more, okay. However, if you move to the rear pilot, towards the rear pilot, you will have the finishing teeth. Again, the range is there, and the gap is very less, and also the height difference will also be very less in case of the finishing teeth. And lastly, the rear pilot again will have the diameter of the maximum size, so the last finishing teeth and this rear pilot dia will be almost similar. Okay, so this is a pull type broach, which is this is a configuration of the pull type broach, or we can say the nomenclature of the pull type broach, which is normally used for enlarging and means the holes which are already been drilled. Okay, now essential elements we have already discussed. What are the essential elements in the diagram? Okay, now the broaches are designed mostly pull type to facilitate alignment and avoid buckling. So normally we have pull type or push type. Apart from this, we have other types of broaches as well, which we'll discuss later. And then number of cutting edges and the pitch depending upon which the work material and the maximum thickness of the material can be removed. Nature and extent of finish required. Okay, what kind of finish you, what kind of surface you want, depending on that also you can make a broach. Different types of broaches are pull type, push type, ordinary cut type, progressive cut, solid type, sectional type, modular type, profile sharpen type, and form relief type. These are the 9 types of broaches which are available. The material which is used for broach, as we know that the broach has to be, or since it's a cutting tool, it has to be of high strength, uh, harder than the workpiece material. It has to be tough enough and definitely wear resistant, because this tool, if you some portion of the tool gets worn out, then the entire tool, it's since a multi-point cutting tool, entire tool uh, will not be of that use. Okay, so so heat resistant, again, the deformation, plastic deformation due to heat generation should be avoided, should be prevented. So the, for ease of the manufacture and resharpening of the complex shapes of the cutting edges, broaches are mostly made of high speed steel. To enhance the cutting speed, productivity, and product quality, nowadays cemented carbide segments can also be, or inserts can also be used here in case of the broaches. So some inserts can be used in because if there is some breakage that takes place, if the tool tip breaks due to some reason, inserts can be replaced. Okay, so uh, so again, for ceramic tools, normally they are not used. Okay, because the broach velocity is very low. Okay, ceramic tools are not used preferably. So geometry of the broaching teeth, I'll quickly move over this. Will not get into the details. I'll quickly show you how the material is removed. So you can see this is one teeth, this is the second teeth. So this is a, you can, similar to a turning process. Okay, wherein we have some amount of rake angle provided here. Okay, and the chip is moving in this direction. So this is the uncut chip thickness, and this is the cut chip thickness here. And see, the rake angle has been provided here, the rake angle, and there is also some clearance angle is there. So this is one tool, and this is the adjacent tool. Okay, both are fixed in one slender rod. Okay, so this is the uh, normally the, we can say, the feed which is provided. Okay, now broaching operation, like any other machining, broaching is also accomplished through a series of sequential steps: selection of broach and broaching machine, mounting and clamping the broach in the broaching machine, fixing workpiece in the machine, planning tool work motions, selection of the levels of the process parameters and setting, and conducting machining by the broach. Okay, how to select the broach and the broaching machine? There are various type of broaches which are available. The appropriate one has to be selected on the basis of the type of job, that is the material of the job, shape of the job, what is the size of the job, geometry and volume of work material to be removed from the job, desired length of stroke, and the broach, type of broaching machines which are available. Okay, broaching machine has to be selected depending on the type, size, and the method of clamping which is used, size, shape, and the material of the workpiece, strength, power, and rigidity required for the broaching machine to provide the desired productivity and process capability. Right. Different type of broaches and their application. Broaching is getting more and more widely used because it is increasing the productivity, reducing the time. Okay, so it can be classified as intern, the means depending on the type of operations that, or we can say applications rather: internal broaching, external broaching, pull type or push type, ordinary cut or progressive cut, solid sectional or modular type, profile sharpened or form relief type. This is another type of classification of broaches. As we have discussed 9 type, you can see that these types are similar to that of the previous ones. Okay, Advantages: very high production rate, much lighter than milling, planning, boarding, etc. High dimensional and form accuracy and surface finish of the product. Roughing and finishing in single stroke of the same cutter, needs only one motion. So design, construction, operation and control are simpler. Extremely suitable and economic for mass production. Limitations: we have only through holes and surfaces can be machined. For lighter cuts we can use, it is low chip load and on hard materials. Very hard materials cannot be broached, or broaching operation cannot be performed on that. Cutting speed cannot be very high. Defects or damages in the broach severely affect the product quality, because the cutting edges gets damaged. The quality or the surface finish of the product also is not that good in that case. Design, manufacture and restoration of the broaches are difficult and expensive, as I have just said a few minutes back, that if some edges, cutting edges gets worn out, then restoration of that broach is very difficult, because it's a multi-point cutting tool. So in that case you can use inserts. So in case some wear is taking place in any of the specific cutting edge, you can replace that. Separate broach has to be procured, and whenever and used whenever size, shape and geometry of the job changes. So specific type of broach is required for specific type of material, or specific type of job rather, we can say, right? And definitely for large scale production this is used. Okay, next we'll move to grinding. Grinding will not start today. I'll require one more class so that we can discuss grinding in detail. Okay, so now I'll stop the lecture here, and I'll open the forum for any question answer session. Okay, so that you can ask any kind of questions. I'll just request you to put your roll numbers in the chat box, so that I can get the details of the number of students who were present.
Hello.
Yes, yes, I'm. You're audible. Tell your name. Hello.
No, no. Welcome, sir.
Okay, go. Okay, go, sir. Okay. Any student has any question regarding this broaching operation? Yes. So again, I'm repeating that in case someone is missing the test, okay, please let me know within
You all will
15 to
attend.
30 minutes of the completion of the test time, after which I'll upload the attendance. Okay, so today I'll start the test, or I'll upload the test at 1 p.m. Okay, and I'll give you around 10 minutes time to complete the test. Okay, number of questions today will be much more than the previous tests. Okay, so and it will comprise of both the cutting temperature and broaching. Okay, as I see there is no question, so I'll end the meeting here. Thank you very much for attending the class. I'll request you to stay at home, keep yourself safe, and uh, study well. Okay, thank you very much again. Goodbye.